Hi, my name's Alan Campopiano, and I've written some software to standardize EEG to EEGLAB format. Of course, standardization is critical for large-scale EEG analysis. The issue is, suppose you're a brain code user and OBI has given you access to a number of studies. The studies reside on brain code, but they may have all kinds of different eccentricities that make the studies impossible to analyze as a whole. For example, they may have different event labels, they may have been collected on different acquisition systems, and so on and so forth. So there are a lot of details that we'd have to handle if we're to analyze the data together. So the goal is to take that data and to put it into some kind of common format, in this case MATLAB or EEGLAB format. Following that standardization procedure, the data should be in a state where we can pipe it to any number of downstream processing efforts like ICA or powerful statistics programs like StatsLab, which I also wrote and you can find on YouTube and on GitHub. We're really concerned now with this standardization procedure and how we might achieve this. There are a number of challenges, of course, like file naming conventions. I use the spread file naming conventions. We will have to develop a metadata scheme. Of course, it's important that the function or the program pipes the raw data to the various EEGLAB import functions. The biggest challenge is how to deal with event labels, how to recode those efficiently. I have a rather explicit way of doing it, and there may be more sophisticated methods that we might use, but the way I'll show you works. As I was writing the software, it became very important that we were able to visualize characteristics of the studies and the subjects within the studies so that before we commit to standardizing a number of studies, we can choose which studies to include and actually even which subjects to include into the standardization procedure. As an option, I've added a light-handed as opposed to a heavy-handed data cleaning procedure called PREP, which removes egregiously bad channels, bridge channels, finds the robust average reference, and removes line noise. The PREP toolbox is very good. I would recommend it, and others are recommending it, such as the developers at Schwartz Center who also develop EEGLAB. Lastly, it's important to have some kind of printout or final report that is a summary of the studies that you kept and the subjects that you kept and the events that you recoded and so on and so forth. Just some document that makes it very easy to see what you've done during the standardization procedure. So I'll introduce you to the function called meta2struct, which stands for metadata to structure or MATLAB structure. I'll just give you a quick walkthrough. So I guess I can just start by showing you, as you well know, the spread naming convention for naming studies and naming subject files, which just go program, study, site, subject. And here in MATLAB, this is my current directory. I follow the same naming convention for my metadata files, which you can see are just here in this directory and have the extension .meta. So let me show you what those metadata files look like. They're very simple. They're just text files with a number of different headers. So here's a metadata file with a number of different headers. We have study name, and there you can see the study name, and a number of other things that we might want to know about this study. For example, the acquisition system or the format of the data, of course the event labels, some descriptions of the events, number of channels, and so on and so forth. And there you can add headers to these metadata files at will. So, for example, if there was a header that was needed for a particular import function, you could just add it, and my function will take care of it appropriately, and I'll show you how that's done. So, for example, we can look at another metadata file. This has most of the same headers as the previous metadata file, but there's also this one here, which is unique to all of the studies that I have. This is the only study that has this header, which is called relative gain, and all this is some number that the import function for this type of data requires. So in order to load data of SMP format, the import function requires that you specify what the relative gain is, and so this header has to be in the metadata file, and my function will take care of piping that appropriately to the import function. So you can see these metadata files can be unique, and you can customize them just by following this basic structure. Okay. So let's run the function and see what happens. So the function's called meta2struct, as I mentioned before, and there's an option to do the prep cleaning. I'm going to select no prep just because prep takes a while and I've already done it. I'll show you a back-to-back comparison of prep cleaning versus not prep cleaning in a second, but for now I'll just standardize the files without any particular pre-processing technique. So the first thing is the function will ask you to grab the metadata files for the different studies that are in your workspace. And then an interface will come up. And let me just clean things up here so the interface is easier to see. Okay, here we go. As you can see, each metadata file of course corresponds to a particular study, and these are all piped dynamically to this graphical user interface. So here we're dealing with the first study here, AAA01TWH, and we can expand this study and see a number of things. Well, first of all, we can see the details of the study. So if you look at this bottom pane here, you can see that it was collected in the BDF format, and of course this text is being piped to this user interface because of the metadata. And also we can go down here to the event labels and see the descriptions of the different event labels. Okay, and there are a number of other fields like the channel locations, the number of channels. There's this no data channel, and we can choose whether we want to include the study or not. So perhaps there's some detail about the study that we decide we really don't want to include this study into our analysis, so we can just click it off. There's also there are also some details of the subjects within this study. So this study clearly has 2 subjects, and you can see they're named properly. And we can click on the subject field and expand this pane down here and see a number of details on this subject: the gender, the handedness, the age, and so on and so forth, and some other details perhaps that might be interesting to us, like, oh, this subject fell asleep during the study, so maybe we would not want to include them, and we can just click it off if we want to. But I'll just well, here I'll just click off the second one, and so on and so forth. This is just the first study, but you can look at all kinds of different all the different studies, and they will have slightly different fields based on the metadata for that study. So this particular study has sampling rate listed as a field because the metadata had a header called sampling rate, and this field is important because this particular data format requires sampling rate to be specified as an input argument in order to import the data properly. So that's included, it must be included. Now, when it comes to recoding the events, as I said, I have a very explicit, rather manual way of doing that. Here are the events listed in the event labels, rather listed in red, as to indicate that these fields require you to take action. And here you can just click on the field and recode these events as you wish. So here, any instance of E1 or event label 1 will get recoded to face, and any instance of E2 will get recoded to house, and so on and so forth. And we can just leave the other events as is if that's what we want to do, and that's what I'm going to do. And so you would just go through all of the different studies and relabel the events manually the way you want. Okay. So we can click OK, and things will begin to standardize. I'm just going to wait for this to finish. But I will say that the running time of this function, of course, is proportional to how long it takes for you to load the data. The rest of the things that are going on behind the scenes, like the parsing of the metadata, and all of the other aspects of the code, are really quite trivial compared to the time it takes to load the data. So that's where the bottleneck is. So I'm just going to wait for this to finish. It shouldn't take too long. Okay, it's done now, so it's all the files are standardized, and we can see now that we have a directory called standardized files with all of the standardized files inside of it. So that's good. So they're all in the EEGLAB format now, which is denoted by this .set. And a couple more things before I go. I did want to mention this or show you this prep paper. So this is the paper here. Again, this prep pipeline is ideal for large-scale EEG analysis. So this is perfectly in line with the brain code mandate. So I do think it's a good idea, and I encourage you to check it out. And I do have an example here of prep versus no prep, and see if I can give you a A/B comparison here. So on the left we have something that's been cleaned with prep, and on the right we have a file that's standardized into the EEGLAB format but not cleaned with prep. On the right you'll see two rather noisy channels, C1 and C2, and on the left you'll see that those two channels have been automatically removed. So that's good, and I think there's even a flat channel in here somewhere. Yeah, so D1 is a flat channel, and you can see that on the left, D1 was removed by prep. So this is good. Prep is good. Check it out. And the very last thing I want to show you is, as I mentioned, it's nice to see a report of what was accomplished during the standardization procedure. So this is the report that my function will give to you afterwards, which is just a nice bird's eye view of everything that was done. So in these little blocks here, you'll see what was done on each study. So if you look at the first block, you can see the study name here and the different event labels that exist in the file now. So any instance of E2 was changed to face, and any instance of E4 E1, E2, E3, E4, right? And now we have face and house added. So this is saying E1 was changed to face and E2 was changed to house, and then we also have E3 and E4, and so on and so forth. And also, you remember we clicked off of that second subject. We did not include that second subject in the standardization procedure, so there's a 0 next to this subject. Okay, so this is the standardization procedure, and I hope it's useful to you. And if you have any questions, just let me know. Thanks for listening. Bye.